So Wisconsin Robotics is a student organization here at the University of Wisconsin-Madison. We are comprised of around 30 to 40 active members. So Wisconsin Robotics is currently building a robot for the University Rover Challenge. So for the critical design review, we have a drivable rover. The robot we're designing's name is Insomnia. So Insomnia has been designed so that the mechanical, electrical, and software components will work together in order to tackle all the different challenges that URC throws at us.
For Insomnia, we ended up deciding on using a rocket bogie, and it was actually a pretty lengthy process because towards the start of the year we talked about what we needed to accomplish with our drive system with the rocket bogie, and it was just far and away was the most effective drive system we had for the variety of tasks it needed to perform. It's a suspensionless suspension, right? Because it doesn't have shocks, but it can still get over things, and it functions much in the same way that a suspension would. Regarding the arm, you want to keep it as simple as possible. We didn't need a ridiculous range of motion to use, only motors. So we actually end up going with a linear actuator system because, again, we don't need to necessarily be reaching all over the place. So I would say that the wheel is the most complex system on the robot, and I would be mostly proud of that. I mean, the wheel is not really something you can reinvent, but the way we tackled the issue with our wheels being that we couldn't really fit a motor inside the frame. So we instead opted to just design a wheel with a motor being inside of the wheel itself.
A few of the projects that Embedded has been working on are our 400 megahertz wireless system. We've basically taken this all from scratch. We've even made our own custom antennas. Our whole goal is to be able to not be impeded by the landscape out in Utah, and also to be able to have as much throughput as we can. The Talon SRXs for our motor controllers are normally adapted for First Robotics. We've taken this and we are currently using the PWM capability to where we are able to use it with our X Mega microcontroller to control motors, be able to drive around. The X Mega microcontroller, where it is a 8-bit microcontroller capable of, I want to say, 40 GPIOs, so that we'll be able to connect all of our microcontrollers, all of our sensors, and anything else.
We've been using something called the JAWS protocol to communicate with our robots. We've developed our own in-house C# library, badgerjaws.net, which we've developed over the past 2 years from an initial Java code base. We've verified and used JAWS for multiple robots, and we've verified that it's very reliable.
Our video streaming system was actually built in-house. So we chose to do this because any sort of generic system is going to have a lot of overhead and is not going to be exactly built for what we want. One of the main subsections of the software team is the autonomous drive section. So that section would kick in the case that the robot loses connection from the command and control center.
Since Insomnia hasn't been handed off to software to do full development on, the autonomous team has been developing on an alternate robot based on the iRoomba, which they've successfully gotten working with a basic reactionary drive system. That work can very easily be translated onto Insomnia.
So the way we came up with the name for our robot, Insomnia, was actually, I think, inspired by the vice president mentioning that I really should go home one night and go to sleep. It's starting to become the norm for the team to stay up really, really late, so I think we kind of embody the name that we chose.
The core of Wisconsin Robotics is a group of incredibly motivated individuals. With our preparation for URC, the solid core of the team has put in a lot of hours over the past couple of weeks, and the gains that we've seen in the robot's development have been extraordinary. I have no doubts that we'll have a solid robot by June.
We will continue to refine all the various subsystems and improve them, making them more reliable and just robust in general. Our robot is drivable at the critical design review, and having that amount of lead time before the competition itself will allow us to thoroughly test every single subsystem on there to ensure that we will be performant at competition.